We are diving into a survey on Agent as a Judge by Renyang Yu and the team. This paper really documents one of the most crucial shifts happening in AI evaluation right now. We're talking about the move from the old LLM-as-a-Judge idea to this much more robust, verifiable Agent as a Judge framework.
It's a fundamental change, yeah. I mean, for a while, we've known that traditional LLM judges have some serious problems. They've got these inherent biases. They might like longer answers better or answers that sound like their own training data. And their reasoning is pretty shallow, single pass. Plus, they have absolutely no way to check their work against the real world. They can't run code. They can't search for facts.
And the survey's big insight is that the fix isn't just a slightly better LLM, it's a completely different kind of entity, an active agent, an agent that can plan, use tools, even work with other agents. And it has memory. All of this allows for assessments that are way more robust and, I think this is the keyword, verifiable.
Exactly. And this survey gives us the first real unified framework for this whole field. It lays out the core methods, the applications in really high-stakes areas, and it charts this evolution through three clear stages. You've got procedural, then reactive, and finally the really cutting-edge self-evolving agents. It's basically the roadmap for where evaluation is going next.
Okay, let's really unpack this. Before we get into the agents themselves, we need to nail down why the old LLM-as-a-Judge setup just hit a wall. I mean, it was a big step forward, right? It helped with scalability and understanding nuance. So what were the big constraints that forced this pivot?
Yeah, you're right. It was a step up, but hit three fundamental problems that just, undermine the trust you can have in the evaluation.
Yeah.
The first one is all about parametric biases and complexity. Think about it. If you train a judge model on, say, 50,000 examples of very polite, kind of verbose AI responses,
it's going to develop a taste for that style.
It's going to develop a taste for it, exactly. So this single-pass evaluator will unconsciously favor outputs that look and feel like it's training data, even if a shorter, more direct answer is actually better or more accurate.
So if you have a model trained on dense legal text and the judge was trained on similar stuff, it's just going to naturally give higher marks to answers that sound like a lawyer wrote them, whether they're right or not.
Precisely. The judge is basically biased towards models that talk like it does, or just talk more.
Mm-hmm.
And that kills its ability to fairly judge something new or creative.
Okay, that makes sense. What's the second big problem?
The second one is this huge issue of passive observation versus reality.
Yeah.
A naive LLM judge is, well, it's a passive observer. It judges based on linguistic plausibility, how correct something sounds,
It can tell a good story, but it can't check the receipts.
That's the perfect way to put it. This leads to what the paper calls hallucinated correctness. It's especially dangerous when the AI's output is supposed to do something in the real world, like run code or control a robot. The judge can't check that. It just reads the code and says, yep, looks plausible to me.
And if there's a tiny syntax error that breaks everything, the passive judge just sails right past it.
Sails right past it. Because it's relying purely on its internal static knowledge. It can't collect any new evidence.
Okay, so you have bias and a complete disconnect from reality. What's the third constraint?
It's cognitive overload and granularity. So imagine you're trying to grade a complex research paper. You need to check for coherence, factual accuracy, creativity, citations, a dozen different things. Trying to cram all of that into one single thought process, one inference step, is just too much.
You just get a single vague score at the end, like a B-.
Exactly. A coarse global score that doesn't tell you why it's a B-. It can't pinpoint the specific flaws, which makes it basically useless if you're trying to actually improve the model you're testing.
So the whole idea behind Agent as a Judge is to turn that passive, single-minded LLM into an active thinking system. The paper highlights three big evolutionary leaps in capability that make this happen.
Yes, it evolves along three key vectors: robustness, verification, and granularity. Let's start with evolving robustness. From monolithic to decentralized, this one directly attacks that bias problem we talked about. Instead of one judge, you create a team of specialized agents.
So instead of one professor grading everything, you're building an expert panel, a jury.
The jury is a fantastic analogy. You could decompose a big evaluation goal, like assessing a medical diagnosis. You might have one agent check for factual accuracy against medical literature, another for patient communication style, and a third for ethical guidelines. You can inject domain-specific knowledge that a generalist model would just miss.
And I'm guessing these agents can argue with each other.
They can, and they should.
Yeah.
This multi-agent deliberation, this debate, it forces them to check their own cognitive shortcuts. It makes the final judgment way more robust because it's not just one LLM's opinion.
Okay, so that handles robustness. How do we get from that hallucinated correctness to, actual correctness? How do you bridge that reality gap?
That's the second evolution, evolving verification. From intuition to execution, this is huge. The agent actually interacts with the outside world. It replaces that fuzzy gut feeling intuition with hard, tangible execution.
So for a coding task, it doesn't just read the code.
It runs it. It uses a code interpreter to see if it works, checks the output, looks for errors, measures performance. For a factual claim, it uses a search tool to see if it holds up against current information online. It actively goes out and finds objective proof.
It's moving from being a literary critic to a scientist running an experiment on the response.
That's it, exactly.
Right.
And that brings us to the third one, evolving granularity, from global to fine-grained. This is how we get past that vague B- score. The agent turns evaluation into a multi-step, autonomous process. It uses memory to track its reasoning, to connect different pieces of evidence it finds.
So it might see a factual error from the search tool and a logical flaw from the debate phase, and it connects those dots.
Precisely. And because it's tracking all this, it can give incredibly specific feedback. It can pinpoint the exact line of code that failed or the specific logical leap in an argument that was flawed. That's feedback you can actually use to make the model better.
This all feels so much more strategic. But, the word agent gets thrown around a lot. It can be a bit of a loose term. So the authors gave us a really clear roadmap with 3 stages of development.
Yeah, this roadmap is one of the most useful parts of the paper. It helps you place where any given system actually is on the spectrum of autonomy. The first stage is the procedural agent-as-a-judge. These systems break up the process, but they do it into predefined workflows. The discussions between subagents are structured and follow fixed rules.
It's like one of those old phone menus, right? Press 1 for this, 2 for that. You can't really go off script.
That's a perfect analogy. It's constrained by predetermined rules. Early systems like Chatty will work this way. The next step up is the reactive agent-as-a-judge. This is where it gets more interesting. This stage allows for adaptive decision-making. The agent can choose different paths or tools based on what it finds along the way.
So if it's evaluating an answer and it suddenly sees math, it knows to call a calculator or a theorem prover tool. It's reacting to the content.
Exactly. It's still working within a fixed set of choices, a fixed decision space, but its path through that space is dynamic. Systems like AgentTX are great examples of this. But the final stage is the really exciting one, the self-evolving agent as a judge. This is the cutting edge. We're talking high autonomy and the ability to actually refine its own internal components while it's working.
What does that mean in practice? Refine its internal components.
It means it's not stuck with the rule book it started with. It can create new evaluation rubrics on the fly. It can update its own memory with lessons it's learned from past judgments. A system like Evil Agents can do this. It's not just following the rules of being a judge. It's actively getting better at the job of judging.
Okay, now let's get into the technical core. How are these things actually built? The survey breaks the methods down into 5 key pillars.
Right. So let's start with multi-agent collaboration, which we touched on. This is the main way to get around single LLM bias. You've got 2 main approaches here. There's collective consensus, which is that horizontal debate model like a jury. And then there's task decomposition, which is more of a divide and conquer strategy. You break the problem down and give pieces to specialized agents. What's really cool in the self-evolving models is that the system can actually create new domain-specific experts as it learns.
So it's building its own dream team.
Yeah.
Okay, what about planning? How is planning for a judge agent different from a regular agent that's just trying to, say, book a flight?
It's about planning the evaluation itself. The most basic level is workflow orchestration, which can be a static plan. But more advanced agents do dynamic, multi-round planning. The evaluation agent, for instance, can decide on its own, okay, I have enough evidence now, I can stop, instead of just running a fixed number of steps.
But the real game changer you mentioned is that they can discover their own criteria.
That's rubric discovery, and it's the signature of a self-evolving agent. Instead of a human giving it a checklist, the agent figures out what the checklist should be. Say it's judging a new biotech proposal. It could use a search tool to find the very latest industry standards for safety and then build a custom rubric based on those findings. It's asking, for this specific problem, what does good actually mean?
That's a massive leap. Okay, next up is tool integration. We know it's about grounding, but how do they use tools differently?
The use is very deliberate. It's split into evidence collection and correctness verification. Evidence collection is about gathering the raw materials, code execution traces, search results, things like that. Correctness verification is about running explicit checks. A system like Hermes uses formal theorem proving for math. Verify agent uses code interpreters. The verdict isn't just, I think this is right, it's, I ran the proof, I executed the code, and I can verify that it works.
So memory holds it all together. What role does memory and personalization play in keeping all this coherent?
Memory is absolutely vital for consistency in these complex multi-step tasks. At a basic level, it's about intermediate state tracking, remembering the steps in a proof or the output of a tool call. But the really advanced application is personalized context. The agent can store user preferences or specific quality standards for different teams and apply them consistently over time. A system like RLPA can build and maintain user personas to tailor its judgments.
And finally, how do we make these complex judges even better? What are the optimization paradigms?
There are two main approaches. First is training time optimization. This is where you actually update the judge model's parameters, often using reinforcement learning, or RL. RL is so important here because it lets the agent internalize complex behaviors, like knowing when to use which tool. It's not just following a prompt, it's learning a skill.
So you're changing the judge's brain, not just its instruction.
Exactly. And the other level is inference time optimization. Here, you adapt the judge's behavior without changing the model's weights. This could be a fixed procedure, like a multi-round debate, or it could be dynamic, where a meta agent is monitoring and correcting another agent's evaluation in real time.
This is a huge shift. So what does this all mean for people actually building AI systems? Where are we seeing these agents being used today, especially in the really critical areas?
Well, we're seeing them deployed across two major areas. In general domains, the big theme is verification. For math and code, we're moving past just getting a score. Hermes validates reasoning against formal proofs. Popper tries to actively falsify claims using statistical tests. In fact-checking, it's now an interactive process, not a static prediction.
And what about the high-stakes professional domains? That seems to be where this verifiable approach is an absolute must-have.
Oh, absolutely. In law, you have systems like agents court that create an adversarial debate. You have agents playing the prosecutor, the defense, and the judge to make the final verdict more robust. In medicine, you've got multi-agent systems like MAJ-Eval that break down clinical quality into different specialist roles to ensure nothing is missed. And you even have agentic simulators like AI Hospital that are used to critique and train other medical AI models.
What about finance? The risk there is enormous.
Right, so in finance, the focus is on auditing the agent's decision-making process, its trajectory. Systems like SAEA can check for hallucinations or temporal errors in an agent's reasoning. And when you scale that up to multi-agent financial systems, you can trace complex failures, like when different agents start to diverge in their strategies. It's all about safety and reliability.
It sounds like this adds a lot of reliability, but it must also introduce a new set of challenges. The complexity, the computational cost must be huge.
It is. That's the trade-off. The big challenges are cost, latency, safety, and privacy. Computationally, it's way more expensive. You're going from one quick inference to a whole multi-step, multi-agent process with tool calls. Training these things with RL is also very costly. And inference takes longer. There's a delay.
But I wonder, isn't some delay acceptable if the result is actually trustworthy, especially in medicine or finance? Where do you think that reliability latency trade-off lands?
That's the exact tension that engineers are dealing with. For something real-time, like moderating live comments, a long delay is a non-starter. For verifying a complex financial model that will manage millions of dollars, a 10-second delay is nothing if it guarantees accuracy. And on top of that, you have new safety concerns. Using tools opens up new attack surfaces, and privacy is a big one.
Right. With all that memory and personalization, you're storing a lot of potentially sensitive data.
A huge amount, especially in law and medicine. If you're storing user profiles or case histories, the risk of data leakage is significant. It demands a whole new level of security architecture.
So given those hurdles, where does the survey point us? What are the big research directions for people in the field who are listening?
The future is all about pushing for true autonomy. First is personalization. We need agents that can proactively manage their memory of user preferences, knowing when to add, update, or even forget things. Second is generalization. This means agents that can generate their own context-aware rubrics on the fly, adapting to the task's unique complexity instead of using a one-size-fits-all approach.
And what about how the judge interacts with the world?
That's interactivity. The agent becomes an active experimenter. It will dynamically design evaluation tests to find edge cases. And it will need to collaborate with humans, what the paper calls human-agent collaborative calibration, to sort out ambiguous or subjective judgments. And finally, for optimization, the field really needs to lean into training-based optimization. We need to use RL to really bake these complex agentic skills into the models themselves, so they aren't just following a long prompt.
We've really traced this profound evolution from a simple passive score to these incredibly strategic, self-improving, and verifiable systems. It completely redefines AI evaluation.
It does. And if you step back and look at the big picture, the next generation of judge agents won't just be following a protocol. They're going to have to become genuinely autonomous entities that can perceive, reason, and learn right alongside the very models they're judging. That's the only way to get truly reliable evaluation in these high-stakes fields.
Which leaves a really interesting question for you, the researcher, to think about. If these evaluation agents can autonomously create their own rubrics and actively manage user preferences and adapt their whole workflow, are we getting to a point where the judge is actually more complex and adaptable than the AI being judged? And what kind of new alignment challenges could that create? That's it for this deep dive into a survey on agent as a judge. We look forward to seeing where these roadmaps lead the field next.